Download this code from codegive.com, link in the description below. tryhackme Overpass 2 Walkthrough, a detailed guide to incident analysis. Overpass 2 on tryhackme is a fantastic room that simulates a real-world cybersecurity incident. It focuses on analyzing server logs, network traffic, pcap files, and other artifacts to identify the root cause, timeline, and impact of a potential compromise. This guide provides a comprehensive walkthrough, explaining the tools and techniques used, along with code examples, to solve the room. Room Overview *. The room presents a scenario where suspicious activity has been detected on a server. You are tasked with investigating the incident using various log files, web server access logs, authentication logs, network captures, pcap, and other information to determine what happened, when it happened, who was involved, and what impact the incident had. Objectives *. Analyze web server access logs to identify suspicious requests. Examine authentication logs to detect brute force attempts or unauthorized access. Investigate pcap files to understand network traffic and identify malicious payloads. Reconstruct the attacker's actions and determine the extent of the compromise. Determine the root cause of the incident and identify vulnerabilities exploited. Tools used *. Command line tools *. grep, awk, sort, unic, wc, cut, curl, bookit, sed, nano, or your preferred text editor. Log analysis tools * go access, log parser, or your preferred log analysis tool, optional but recommended. Network analysis tools * Wireshark, dump, chark. Python * used for scripting tasks like pcap analysis and data processing. CyberChef * a versatile browser-based tool for encoding / decoding, hashing, and data manipulation. Let's dive in. Here's a breakdown of the tasks and solutions ***. Task 1, Initial Reconnaissance and Questions. This task involves answering basic questions about the environment and the files provided. Start by connecting to the tryhackme VPN and deploying the Overpass 2 machine. 1. Download the provided files *. You'll have a compressed archive containing access logs, authentication logs, and a pcap file. 2. Extract the files *. Use the unzip command to extract the contents. 3. Question 1. What is the IP address of the compromised host? Approach *. The room description often provides clues. Also, the file names, example access.log, often indicate which IP address they pertain to. Look for an IP address prominently featured in the files or descriptions. Answer usually something like 10.10.x.y, this value will be specific to your deployed instance. It's essential to review the provided information. 4. Question 2. What is the name of the service running on the compromised host? Approach * the logs and pcap will point to the type of service running. For example, access.log strongly suggests a web server. Examine the ports in the pcap. Port 80 or 443 strongly indicates http/https. Answer web server, or HTTP service. 5. Question 3. What is the log file type that stores information about access requests to a web server? Answer access logs. 6. Question 4. What is the log file type that stores authentication attempts to a system? Answer authentication logs. Task 2. Investigating the web server access logs, access.log. This task focuses on analyzing access.log to identify suspicious requests, unusual user agents, and potential attack patterns. One initial exploration * start by examining the logs to understand their format. Use head and tail to see the first and last few lines. 2. Analyzing the most frequent IP addresses * identify which IP addresses are making the most requests. This can help you pinpoint potential attackers. Explanation awk print $1 access.log extracts the first field, IP address, from each line of the access.log file. Sort sorts the IP addresses. Unix counts the occurrences of each unique IP address. Sort nr sorts the results numerically in reverse order, most frequent first. Head displays the top 10 results. 3. Analyzing user agents * investigate the user agent strings used in the requests. Unusual or malicious user agents can indicate automated tools or attacks. Note * the position of the user agent might differ. Ensure $11 points to the user agent. If not, adjust accordingly. Look for blank or missing user agent strings. Suspicious user agent strings containing words like crawler, scanner, exploit, or automated tool names. Uncommon or unexpected browser versions. User agent strings that are very long or contain strange characters. 4. Analyzing HTTP status codes * look for unusual status codes. 404, not found, errors can indicate probing for vulnerabilities. 500, internal server error, errors might suggest a successful attack. Pay attention to a large number of 404 errors, which might indicate a directory traversal or file enumeration attack. An unusually high number of 500 errors. 301 or 302 redirects, especially if they lead to suspicious destinations. 5. Analyzing specific URLs * look for patterns in the requested URLs. This can reveal the attacker's target. Look for requests to common web application vulnerabilities, example /wp-admin, /admin, /config.php. Requests for files that should not be publicly accessible, example database configuration files, sensitive scripts. Requests containing suspicious parameters, example SQL injection payloads, command injection attempts. Example questions and solutions, access.log. Question, what is the most common HTTP status code in the logs? Solution use the command above to analyze HTTP status codes. The most frequent one will be your answer. Often 200 OK. Question, what user agent string is associated with a large number of 404 errors? Solution you'll need to combine the user agent and status code analysis. This can be done with awk. For example, this finds all lines with a 404 status code and prints the associated user agent, then counts the occurrences. Question, what URL is being requested with the most 404 status codes? Task 3, investigating the authentication logs, auth.log. The auth.log file records authentication attempts to the system. This is valuable for identifying brute force attacks, failed login attempts, and successful logins from unexpected locations. One initial exploration * examine the logs to understand their format. Use head and tail. 2. Filtering for failed attempts * look for entries indicating failed authentication attempts. These often contain keywords like failed, invalid user, authentication failure. 3. Identifying brute force attempts *. Look for patterns of multiple failed login attempts from the same IP address within a short time frame. This is a classic sign of a brute force attack. Explanation *. Grep failed password for invalid user auth.log, filters the auth.log for failed password attempts. Adjust the string to match the failure message in your auth.log file. *awk print $11, extracts the IP address, the field number might vary, adjust accordingly. Sort Unix sort nr head, counts the occurrences of each IP address and displays the top offenders. For analyzing successful logins *. Look for successful login attempts from unusual IP addresses or at unusual times. Explanation *. Grep accepted password auth.log, filters the auth.log for successful password logins. Adjust the string to match the success message in your auth.log file. *awk print $11.9, extracts the IP address and the username. Sort Unix sort nr head, counts the occurrences of each IP address and username combination and displays the top results. This helps identify successful logins from unexpected locations or by unexpected users. Example questions and solutions, auth.log. Question: how many failed login attempts were recorded in the auth.log file? Solution Question: what IP address had the most failed login attempts? Solution Use the brute force detection command from above. Question: what username was the target of the most failed login attempts? Solution Task 4, investigating the network traffic, pcap file. The pcap file contains a recording of network traffic. Analyzing this traffic allows you to identify malicious payloads, exploit attempts, and communication patterns. 1. Open the pcap in Wireshark *. Wireshark is the primary tool for analyzing pcap files. It provides a graphical interface for filtering and inspecting packets. 2. Filtering for HTTP traffic *. Since the web server is involved, start by filtering for HTTP traffic. 3. Examining HTTP requests *. Inspect the HTTP requests to identify suspicious URLs, post data, and user agent strings. Right-click on a packet and select follow-TCP stream. This allows you to view the entire HTTP request and response. Look for *SQL injection attempts. Example: select * from, union select. Command injection attempts. Example ID, WOAMI. File inclusion vulnerabilities. Example // etc. /password. Suspicious data in the post request body. Example: encoded data, commands. 4. Filtering for specific IP addresses *. If you identified a suspicious IP address from the logs, filter for traffic to or from that IP address. 5. Filtering for specific ports *. Investigate traffic on common web server ports, 80, 400, and 43. 6. Analyzing data transfers *. Look for large data transfers, which might indicate data exfiltration. 7. Identify post request body *. Use the following chark command to export the post request data. Change the capture file and other appropriate values. Example questions and solutions, pcap file. Question: what is the user agent string used in the HTTP request containing a SQL injection payload? Solution filter for HTTP traffic, HTTP, identify packets containing SQL injection attempts, look for keywords like union select, and examine the user agent string in that packet. Asterisk question, is there any evidence of data exfiltration in the pcap file? If so, to what IP address? Asterisk solution asterisk look for large data transfers from the compromised server to an external IP address. This might involve filtering for specific ports, example port 21 for FTP, port 22 for SSH, and examining the content of the transferred data. Asterisk question, is there a command injection attempt in the pcap? If so, what is the command? Asterisk solution asterisk filter for HTTP traffic, examine the post data and URLs for shell commands, example ID, woami, cat /etc/ password, and decode any encoded data to reveal the actual command. Python scripting for pcap analysis, example. Python can be used to automate pcap analysis tasks. Here's a simple example using the scapy library to extract HTTP requests and URLs. Explanation asterisk. Asterisk scapy.all, imports necessary modules from the scapy library. Asterisk road pcap file, reads the pcap file into a list of packets. Asterisk packet.hasLayer, TCP, and packet.hasLayer, HTTP request, checks if the packet contains both a TCP layer and an HTTP request layer. Asterisk packet HTTP request.path.decode, extracts the URL, path, from the HTTP request layer and decodes it from bytes to a string. Asterisk the if __name __ main __ block ensures that the code is executed only when the script is run directly, not when imported as a module. Asterisk this script extracts the URL from each HTTP request and prints it to the console. You can expand this script to extract more information, filter for specific requests, and perform other analysis tasks. For example, you could extract the user agent, the HTTP method, and the request body. You can install scapy with pip install scapy. Task 5, reconstructing the attack and identifying vulnerabilities. By combining the information gathered from the access logs, authentication logs, and pcap file, you should be able to reconstruct the attack sequence and identify the vulnerabilities exploited. 1 timeline of events * create a timeline of events based on the timestamps in the logs and the pcap file. This will help you understand the order in which the attacker performed actions. 2 root cause analysis * determine the vulnerability that allowed the attacker to gain initial access. This might be *SQL injection, *command injection, *file inclusion, *weak authentication, *outdated software. 3 attack steps * outline the steps the attacker took after gaining initial access. This might include enumeration, discovering information about the system, privilege escalation, gaining root or administrator access, data exfiltration, stealing sensitive data, persistence, establishing a way to regain access later. 4 impact assessment * determine the impact of the attack. This might include data breach, loss of sensitive data, system compromise, loss of control over the server, service disruption, downtime or unavailability of the service. General tips for overpass 2, and incident response in general. Pay attention to timestamps. Timestamps are crucial for correlating events across different log files and the pcap. Ensure you understand the time zone used in the logs. Decode encoded data. Attackers often use encoding, base64, URL encoding, to obfuscate their payloads. Use CyberChef to decode this data. Use grep effectively. Master the grep command. It's an indispensable tool for searching logs. Use regular expressions to refine your searches. Automate with scripts. Use Python or other scripting languages to automate repetitive tasks and analyze large amounts of data. Document everything. Keep a record of your findings, the commands you used, and your reasoning. This is essential for reporting and future reference. Think like an attacker. Try to understand the attacker's goals and the techniques they might use to achieve them. Conclusion. Overpass 2 provides a realistic and valuable experience in analyzing cybersecurity incidents. By mastering the tools and techniques described in this guide, you can develop your skills in log analysis, network traffic analysis, and incident response. Remember to practice, experiment, and continuously learn to stay ahead of evolving threats. Good luck.